Welcome and thanks for joining the Module 1.1, Introduction to the Quantum Inspire platform. In this module, you will get familiar with a brief history of quantum computing and the current status. Also, we will introduce the QuTech Institute and its demonstrators. Finally, we will have a closer look at Quantum Inspire, the multi-hardware quantum computing platform from QuTech. Quantum computers offer the promise of solving computational problems that are far beyond the reach of most powerful supercomputers, with broad applications that connect to the important challenges of our time. Based on quantum bits that can be 0 and 1 at the same time, and instantaneous correlations across the device, a quantum computer acts as a massive parallel device with an exponentially large number of computations taking place in parallel. There already exist many algorithms that take advantage of this power, for example in the field of chemical processes and the development of new materials in medicine. Many more future applications of quantum computers are anticipated. The foundations for quantum computing were laid down in the early 20th century by, for example, Bell's inequality and quantum information theory. In the late 20th century, around the 80s till the end of the millennium, several quantum computing algorithms, like Shor's algorithm, were defined, and also the criteria for a quantum computer written down by David DiVincenzo. In the first 2 decades of the 21st century, the first transmon superconducting qubit was realized, and several companies started to work on the realization of quantum computers. Many companies are working on quantum computers with different technologies. For example, Intel, HRL Laboratories and NTT are working on spin qubits in semiconductors. Google, IBM and Rigetti are investing in superconducting qubits. D-Wave is producing a superconducting quantum annealer. Currently, progress is made in error mitigation and correction that promises to significantly shorten timelines for the advent of universal fault-tolerant quantum computers. In 2023, more than 40,000 quantum technology-related publications worldwide were created, and almost 5,000 quantum technology-related patents were granted in 2022. At this moment, there's not a clear winning qubit technology. As an example, you can see the roadmap of IBM in quantum computing displayed here. IBM is, at this moment, one of the largest players in the field of quantum computing. Their roadmap and number of qubits ranges from several hundreds of qubits at this moment till over 1 million qubits within 10 years from now. What about the economics of quantum computing? The forecasts for the market size of quantum computing are quite optimistic. McKinsey's analysis shows that the market size in 2035 for quantum computing is expected to reach about $28 to $72 billion. Private and corporate funding for quantum technology startups has been significant during the last years, but funding has been slowing down a bit recently. On the other hand, public funding that was announced by several governments remains to be high, showing a spending of about $42 billion. There are about 260 quantum computing startups with about $6.7 billion investment. In terms of technology, we see more emphasis on quantum control, error correction and mitigation, and logical qubit demonstrations, which are important for fault-tolerant quantum computing and useful applications. From the applications point of view, the largest value impact of quantum computing is expected to be in the area of financial services, automotive, life sciences, and chemicals. QuTech in Delft is the mission-driven research institute for quantum computing and quantum internet, a collaboration founded in 2014 by Delft University of Technology and the Netherlands Organization for Applied Scientific Research, TNO. Its mission is to create the quantum future from world-class research to world-changing innovation. The goal is to create scalable prototypes of a quantum computer and a quantum internet and building and supporting the ecosystem. To realize its mission, QuTech has built several demonstrators to make quantum technology accessible to a wider audience and future users. Currently, there are 2 demonstrators: the quantum computing demonstrator called Quantum Inspire and the quantum internet demonstrator called Quantum Network Explorer. A quantum computer doesn't only consist of qubits, it requires a full stack of different functional layers, like a user interface, a compiler, and a quantum computing language. Our quantum demonstrator, Quantum Inspire, is such a full stack quantum computer. The stack includes the quantum processors that consist of different types of qubits. Currently, it includes superconducting transmon and silicon germanium spin qubits. The system architecture connects and translates quantum algorithms to the low-level pulses that operate on the qubits of the quantum processors. By the end of 2017, QuTech decided to start a multi-year engineering project to develop a generic quantum computing platform capable of controlling up to 100 qubits with different backends. The platform was developed during 2018 and 2019 based on the assembled stakeholder and system requirements, including a superconducting qubit, a spin qubit, and a simulation backend. In April 2020, the Dutch minister and the European Commissioner launched Quantum Inspire as the first in the world to host 2 quantum processors with different qubit technology. Quantum Inspire is open and free to use. Anyone interested can program and execute their own quantum algorithms on various hardware chips and multiple simulators. A software development kit is available. Even now, we continue to develop, test and implement innovative software and hardware upgrades. You can find all information on the web portal quantuminspire.com. When you visit the web portal quantuminspire.com, you will see the homepage with an introduction into the demonstrator Quantum Inspire. At the top of the page, there's a link to the knowledge base, where you can find a wealth of information and background on quantum computing and Quantum Inspire. To start working, you have to create your own personal account by using the link My Quantum Inspire at the top. The Quantum Inspire platform allows to execute quantum algorithms using the CQASM language. It also includes a software development kit with an API for the platform backends for Project Q and Qiskit. You will learn more about using the software development kit in one of the later modules. To program your quantum algorithms, you can also use the Quantum Inspire web editor. Here you will see a graphical representation of the quantum gates operating on the different qubits. Again, you will learn more about using the web editor in one of the next modules. Thank you for listening and feel free to start programming your quantum algorithms on our Quantum Inspire demonstrator.